Hello everyone, in this video I am going to be solving this problem called validate binary search tree. So you will be given a binary tree and you need to say whether this is a valid binary search tree or not. So here in this case you can see all the values at the left are less than the value at the root, and all the value at the right are greater than the root. So in order to be a binary search tree, all the values in the left subtree should be less than the root, and all the values at the right subtree should be greater than the root, and this property should be satisfied for all the subtrees recursively. So in this example you can see 4 is not greater than 5, it's less than 5. So all the values in the right subtree should be greater than its root. So here in this case it's completely violating the property, so this is not a binary search tree. So let's try to solve this problem. Now let's think about the range. What is the minimum value that can be present at the left subtree? It can be negative infinity. And what is the maximum value that can present? That should be less than the root. So range for this is negative infinity and 5, which is not inclusive in this case. And what about the range for the right subtree? So the range can be from 6 to positive infinity. So this is the idea behind that. We will create a recursive function and pass the range, and we will check whether the value at the root is satisfying the range or not. So we will keep doing that for all the subtrees, and if that's the case, then this is a binary search tree. Otherwise this is not. So let's try to implement this problem. I'm going to be creating a function called validate bst, so which will take a root. And initially, what is the range? Initially the range should be from negative infinity to positive infinity. All right, now let's write the method. So what is the base case for this recursive call? So recursively calling this method, there should be a case that there is no node or no subtree at all. For that case, that is obviously a binary search tree. So the base case of here should be root is equals to null. Otherwise, what we need to check is that first thing is whether the value within the root is range, the value inside the root is within the range or not. So for that we will have to check root.val is greater than min and root.val is less than max, because that's the range. So again, what we will do is we will recursively call this method to check for its left subtree as well as right subtree. So that will be root.left, and range for the left subtree will be minimum to the current value of the root, which will be the maximum for that subtree, and for right subtree that's gonna be root.val will be the minimum value and maximum value will remain same. So we are done. Let's try to run this code. Okay, this is accepted and submit. Alright, you can see one of the test cases has been failed because this is a maximum value of integer and I'm comparing this with less than operator. So obviously this value is not less than itself. So for that case, it's failing one of the edge cases. So instead of using integer, let's take some bigger data type. And let's now submit the code and it should work. Okay, it's accepted. So that was it for the video. If you like this video, please like, comment, share and subscribe. Thank you.